Alright, so the important things to remember about projectile motion are that motion vertically, the vertical component, acceleration, the only acceleration there is gravity. The only force that acts on an object in projectile motion is its gravitational force. So the only acceleration it experiences is due to gravity, which is vertically down. So that means that in the horizontal component of motion, acceleration equals 0, where of course ignoring air resistance for our calculations. And when we break up the motion into horizontal and vertical components, the one thing that can link those two components together is time. So what we're going to look at in this video is an arc, a parabolic sort of motion. The important thing to know about this is that we can make use of the fact that at half the time that'll be the peak of the motion. And at that point there, the vertical component of the velocity will be 0. If you think about an object going vertically up, it'll stop here, and at this point here its velocity will be 0. Same thing for something in curved motion like this. If we're considering only the vertical component of its velocity, it'll be 0 at halfway through its time. So we're going to use that to solve a problem. Okay, so in this question we have a golfer who is 20 meters from the pin, and he fires a ball at 15 meters per second at 40 degrees to the horizontal. So he's aiming to land just in front of the pin. We're asked to find whether it lands in front of the flag or behind the flag. So what we need to do here, because we're given velocity which is actually at an angle to the horizontal, we need to break this velocity vector up into its horizontal and its vertical components. And we use trigonometry to do that. So we're going to have a horizontal component and a vertical component making up our velocity. So here is u horizontal and u vertical, and that's 15 meters per second at 40 degrees. So you can see from this triangle the opposite side, the vertical velocity, uv will equal 15 sine 40, and UH will equal 15 cos 40. So writing down everything we know, horizontally and vertically. Horizontally, acceleration equals 0, vertically, acceleration equals -10, I'm defining up as positive, and initial velocity. So initial velocity horizontally, so UH, because of this little triangle we've worked out here, UH equals 15 cos 40 degrees, and UV will equal 15 sine 40 degrees. Other quantities we know. Well, we're not going to consider the whole flight. First thing we're going to do is consider only the first half, because that helps us, that gives us a bit more information, a few things more to work with. So for that first half of the flight, we know that the final velocity at its peak will be 0. Not for the whole flight, but for just that half the flight, the final vertical velocity will be 0, and that'll allow us to find t1/2 as our unknown. So best equation to use here would be v equals u plus at. So 0 equals 15 sine 40 equals 9.6. So we get 9.6 minus 10t, and so t, which is only for 1/2 of the flight, but the t equals 0.96 seconds. So it takes 0.96 seconds for the ball to reach halfway through its flight. So if we want to make use of that and bring it over here, we'll times it by 2. And so t for the whole flight will be 1.92 seconds, twice this quantity here. And so now we can go ahead and solve for x, which is our unknown, which is what we want to find, how far the ball travels, the ball's horizontal displacement. So we'll use x equals ut plus 1/2 at squared, and happily for us, because acceleration is 0, this term goes to 0, and so all we get is x equals 15 cos 40, which is 11.5. So 11.5 times 1.92, and so x, the distance, is 22.08 meters. So Greg the golfer has overshot the pin. His ball has landed somewhere here. So what we did there was we first broke up the initial velocity into components horizontally and vertically. Vertical component was 15 sine 40. The horizontal component was the cos ratio, 15 cos 40. And then we can use the fact that at the peak of its flight, at half the time, the vertical component of the velocity is 0. To help us work out the time, that we doubled that time to find the total flight time, to find the total distance.